Hello everyone, we hope that you are enjoying your summer or winter. We have some interesting news from Australia. In this episode, we are going to listen to a book review from Professor Haluk Eren and an interview conducted by Professor Miller with Professor Roberto Bertini, Director of the Center for Urban Transportation Research at the University of South Florida, and the former Deputy Administrator of the Research and Innovative Technology Administration at the U.S. Department of Transportation. This is Dr. Mayam Kaveshkar. Let's begin the news for episode 41, July 2017 from Auckland. A group of hackers gathered in a warehouse in Auckland with their small cars made of simple materials to compete. They painted a track on the ground, and the DIY robocars were designed such to move over the track and finish it. Whoever moves faster and completes the track is the winner. The size of the cars start from a normal go-kart to 1/16 scale. They are not big enough to place an onboard processing unit, so onboard sensors, cameras, sonar, LiDAR, radar, GPS or whatever will transmit the data to a laptop via Wi-Fi connection. All the possible pro-grade AI and robotics software are installed on the laptop. If you are interested, let me inform you that this is a monthly event. For details, read our blog post. Driverless cars can now be tested in New York streets. Since 1979, operating any motor vehicle in New York was prohibited without at least one hand of the driver on the wheel at all time. But the state budget, approved in April, will allow driverless cars onto the streets, but under very strict regulations. A licensed driver has to sit on the passenger seat, and the car has to have a $5 million insurance just in case. Plus, the companies have to pay for police escort. And anyone who wants to test a driverless car has to be approved by the State Department of Motor Vehicles. And do you know why it is so necessary to test driverless cars, their hardware and software in different cities and conditions? It is because the detection system of driverless cars tested in Australia is failing to recognize kangaroos on the road because of the way that they move. David Pickett, Technical Manager Volvo Australia, said, "We have noticed with the kangaroo being in mid-flight, when it's in the air it actually looks like it's further away, then it lands and it looks closer. The system is using the ground as a reference point, and a hopping kangaroo is not recognizable for it. They even move differently from human, which will make everything more complicated." Volvo was successful in detection of large animals in Sweden, but the research team who was sent to Tidbinbilla, Australia, is facing some difficulties with Roo. They have been there 18 months. They are also facing some challenges with Australian roads, such as unsealed roads and unmarked highways, in addition to huge road trains. Volvo will solve the issue, and there will be no delay in introducing of autonomous vehicles in Australia. From this fall, students of Michigan University will be transferred by a driverless shuttle. The university will deploy 2 of these shuttles. They are manufactured by a French startup company called Navia. The shuttle does not have any steering wheel and pedals. Maximum capacity is 15. The trip is free, and it will take place on a 2-mile route between the Lurie Engineering Center and the North Campus Research Complex on Plymouth Road. So dear listeners in Michigan, please go ahead, try it, and don't forget to share your experience with us. This month, Professor Haluk Eren has reviewed a book about the roadside video data processing. He is going to share it with us.
This is the book review section for the present episode of ITSPodcast. Reviewed by Dr. Haluk Eren, Firat University, Elazığ, Turkey. The book title is Roadside Video Data Analysis, Deep Learning, and consists of 189 pages. Written by Brijesh Verma, Ligang Zhang, and David Stockwell. It was produced by Springer Press in 2017. The book elaborates design steps, theoretical methods, and applications regarding deep learning approach for roadside video data processing. It reveals a comprehensive study of feature extraction, segmentation, and classification steps involving in scene labeling, roadside vegetation classification, and vegetation biomass estimation in fire risk assessment. Chapter 1 initially presents background of roadside video analysis. It investigates collection of roadside video data in two groups, which are industry and benchmark data. The chapter also builds up applications of roadside video data. Chapter 2 points out implementation parts of roadside video analysis scheme, addressing required stages for relevant methods. Well-known techniques for feature extraction, segmentation, and classification of objects are included in the chapter, which also consists of related work on vegetation and generic object segmentation. Finally, the MATLAB codes of common data processing algorithms are provided. Chapter 3 introduces some of non-deep learning approaches for roadside video data analysis, and related experiments are provided to evaluate their performance on both industry and benchmark data sets. Chapter 4 tackles with deep learning-based roadside data analysis and their applications. It contains two comparisons, one of which is in between the automatic feature extraction in convolutional neural network CNN and conventional one using the same multi-layer perception MLP classifier. And the second one is in between an integrated architecture of CNNs and a single classifier model of CNN or MLP. The chapter mentions about a novel deep learning network for object segmentation. The state-of-the-art performance on 3 benchmark data sets is assessed. Chapter 5 comprises a case study for roadside fire risk assessment. There is a comparison between the features extracted by CNN and regular base texture and color features. Here it estimates the fuel load level for a roadside grasses dataset using a vertical orientation connectivity of grass pixel algorithm. Eventually, it evaluates classification performance of the regions as fire-resistant and fire-prone. Chapter 6 addresses feature challenges and some issues in question, as well as suggestions for existing research and applications using roadside data. Considering rapid developments of deep learning in various fields, the book discusses the state-of-the-art topics to assess roadside video data analysis via deep learning. Readers interested in roadside-related deep learning applications will discover valuable information in the book.
Thank you, Haluk. Now let's listen to the interview with Professor Roberto Bertini, conducted by Professor Jeffrey Miller.
Hello everyone, I'm Jeff Miller from the University of Southern California. We are here today with Professor Robert Bertini. Dr. Bertini is the former Deputy Administrator of the Research and Innovative Technology Administration at the U.S. Department of Transportation. Recently, he has joined as Director for the Center for Urban Transportation Research at the University of South Florida. Previously, Dr. Bertini was Associate Professor of Civil and Environmental Engineering at Cal Poly San Luis Obispo. He chairs the Operations Section of the Transportation Research Board and is the Chair Emeritus of the TRB Committee on Traffic Flow Theory and Characteristics, where he oversaw the publication of nearly 200 papers, over 1,000 submitted with more than 4,000 reviews. He was Director of the ITS Joint Program Office, member of the ITS America Board of Directors, and professor at Portland State University, where he founded the ITS Lab, Portal Data Archive, and OTREC University Transportation Center. His research interests include sustainable transportation solutions, traffic flow theory informed by empirical and experimental measurements, intelligent transportation systems, multimodal transportation, big data for improving performance measurement, planning and operations, and proactive traffic management and operations. Dr. Bertini has participated in many IEEE, ITS, and IV conferences as associate editor and international program committee member since 2001, reviewer, author with students, and keynote speaker. He is also an IEEE senior member and was elected to the IEEE ITS Society Board of Governors in 2016. Welcome, Dr. Bertini. Thank you so much for joining us today. Can you please introduce yourself to our audience?
Yes, Jeff, thank you very much. It's really an honor to be invited to speak on this podcast, and I want to thank you for the very kind and maybe slightly long introduction. But you covered a number of the aspects of my career. Sometimes I like to say that I've worn a few different hats throughout my nearly 30 years working in the transportation field. First as a practitioner, as a transportation engineer, then entering the research and academic field when I studied at UC Berkeley, getting involved in the use of empirical data from freeway sensors to inform our understanding of traffic flow theory. And then I took a little break in Washington, D.C., serving under the Obama administration at the Research and Innovative Technology Administration. And so for the past 6 years, I've been back in academia and just recently have been very happy to join the University of South Florida here in Tampa as a professor of civil and environmental engineering and as director of Qatar. And one exciting reason that I was interested in coming here to Tampa is that we are the site of one of the U.S. Department of Transportation's connected vehicle pilots here on the Selman Expressway. So there's a lot of exciting transportation innovation happening here in Tampa, and I'm very excited to be a part of it. And as you indicated, I'm also a very proud member of IEEE and very happy to have been engaged for many years in the ITS Society and everything that we're working on together.
Well, great. This is an honor to be able to interview you with this impressive career that you've had so far. I read one of your papers that was published in the IEEE Transactions on Intelligent Transportation Systems. It was titled, "A Theoretical Framework for Traffic Speed Estimation by Fusing Low-Resolution Probe Vehicle Data." You mentioned in that that your method is capable of fusing low-resolution positioning data with other data sources. Can you elaborate what the other data sources are that you're considering?
Sure, and thank you for reading that paper. That was done as a collaboration with one of my colleagues who has also been on the ITS Society Board of Governors, Professor Hans van Lint at TU Delft, and one of his students who came to visit me when I was in Portland. And that paper focused on using cellular phone data at different levels of resolution, and particularly the low resolution signals that are available from mobile phones. As I mentioned a minute ago, for the past 20 plus years, I've been working with multiple data sources, including fixed sensor data, in-vehicle data, from fleet vehicles, automatic vehicle location data, in addition to the mobile phone sources that we worked with in that paper. And then, so fixed and mobile sources in general are very interesting to me, and I think to our field. And I think the availability of vehicle-based data, much higher resolution vehicle-based data, as is being generated in these connected vehicle pilots, like the one here in Tampa, that will be dedicated short-range communications data from in-vehicle devices and roadside devices, are all extremely interesting to us for generating better and more information about actual conditions on our transportation system. And I think since that paper was published a few years ago, there are even more potential sources with more and more different types of sensors both on vehicles and on the roadside, and increasingly in fleet vehicles such as trucks and taxis and so on. So I think this area is continuing to become more and more exciting and more challenging. I think managing the what we called in that paper title, the fusion of data, is a big challenge. And I think there are, for example, fleets that are generating a lot of data about how their vehicles are moving on the network. But at the moment, the constraint might be that they don't know how to process or mine that data to glean useful information for their operations. So I think there are plenty of exciting challenges for us.
And do you feel that this is still a project in the research world, or has it transitioned over into industry?
So I think there's some of both. Some aspects of industry are quite mature in incorporating data that they're generating into their operations. As an example, I think there's still a big need. It's not really equitable across society, though. You might, for example, have a transit agency in a big city that's very sophisticated, that has a lot of data analysts available to them. But then you have smaller or even rural transit agencies, using transit as an example, that may be generating data but not knowing what to do with it, and not knowing how to extract the metrics or combine their data with other sources of data to extract the information that they need. That's something that I think where there's still a need for more research, and maybe it's applied research in a way, but there's still a role, I think, for universities and for centers like ours here at Qatar to engage with practitioners in that arena. I think we are very ripe for more research in how to fuse or merge data from multiple sources. Of course, there are many other issues like privacy and willingness of certain organizations to share their data. I think we have come to a point where there's quite a bit of maturity with some organizations in, let's say, cloud-based resources, but that I think has not yet trickled down to some of the potential sources of transportation-related data.
Okay. And you worked on the Portal Data Archive, which was established about 10 years ago. And by now, I think it has more than about 3 terabytes of data. What is this data, and how can it be used?
Sure. As I mentioned before, when I was a grad student at Berkeley, we started using three-way sensor data. I was in California, so we had a great partnership with the California Department of Transportation. I was also using some data from the City of Toronto in Canada, as well as the Ontario Ministry of Transportation, they were, I would call them visionary in the sense that they maintained their sensors very well, and that they were very carefully archiving their data. And as I said, that was more than 20 years ago. I think they were quite visionary in recognizing the importance of doing that. And over the last couple of decades, several products have been developed. PEMS is still a product that goes by the name of IPEMS under ITERIS. That was developed by a Berkeley classmate of mine, Carl Petty, as well as Professor Praveen Varaya and Alex Gabardonis. And then that basically became a marketable product and is used certainly in California, in Utah, and other places as a transportation data archive and performance measurement platform. And also at the University of Maryland, Michael Pack has developed the RIDIS system, which supports the I-95 corridor, as well as other regions of the country. Portal came about when I was in Portland, Oregon, working with colleagues. So Portland is a smaller urban area, but the Oregon Department of Transportation, the City of Portland, and TriMet, the transit agency there, were really interested in helping us at the university when I arrived. And the story that I like to tell is that they came 3 representatives from those agencies came over to meet with me. I was very excited about meeting with them. And I'll never forget that basically they said, Rob, we're so glad you're here in Portland at Portland State, and we really want to work with you. And we don't have any money, but we have data, and we'll share it all with you. And you can. We would really appreciate it if you would create some sort of data archive, so that we don't have to deal with those with issues with members of the public asking them for data or for consultants or whatever. So that evolved into what is now the Portal Data Archive, which is has been in operation since 2004. It supports both Oregon and Southwest Washington. It is designated as the official ITS data archive for that region in the ITS architecture that's been established for that area. And it includes freeway sensor data, multiple kinds of sensors, inductive loops and microwave. It includes Bluetooth travel time data. It includes data from the transit agency, quarterly performance data, and it includes traffic signal data, pedestrian and bicycle count, and other types of data, weather data, truck way station data. Recently, they added the ability to include vehicle length from the freeway sensors. And so there's a wide range of data sources that are continuously streaming into that database. And it's now being managed by Professor Kristen Tufte at Portland State. And basically, there are freely available tools available for researchers or consultants or even members of the public who would like to look at various performance measures at different levels of aggregation across the whole network, or on particular corridors or particular spots on the network. And it allows you to compare. Because it's been going now for 13 years, you have at least 13 years worth of historical data available to you. So not only can you freely download the raw data, but you can generate reports comparing the current situation to historical conditions. And I guess it sort of speaks to what I think is an important philosophy that exists in the Portland region about freely sharing transportation data collected by different entities, different organizations, and the idea that if you're putting your data out there, then researchers or app developers can take it and develop their own tools and kind of build on the platform provided by the free availability of data. And that, if you want to call it a data culture, I think a collaborative approach. It doesn't exist everywhere, and it doesn't exist all the time. But I think in the Portland region, that's a really special kind of characteristic that exists there. So the idea that agencies are willing to share data with one another, that they're not afraid that there might be errors in the data. But I remember many years ago discussing with a colleague from Texas A&M University, Sean Turner, about the idea that if somebody's looking at your data, they're more apt to find, where there are not only opportunities but also problems. And so having someone interested in using data for productive purpose is actually a good thing. And though some entities still fear a little bit that there might be errors contained in there.
Wow, and that really puts us into the, one of the big areas of research that we have right now is in big data. And with all of those different data sets that you just talked about there, I can only imagine how much work there is to be done there from many different fields.
Yeah, I think it's very ripe. The idea there was, we weren't developing necessarily a product that could be sold or that could be there's still a research and a university student type of atmosphere around the project, but certainly it's a platform, as these other platforms are, for anyone to access. And I think I would say that in more recent years, the U.S. Department of Transportation has also created a data portal for their connected vehicle data, for example. So I think even at the federal level, there have been some great advancements in this area. The Research Data Exchange, or RDE, is the one that's being sponsored by the USDOT.
Yeah, that's great. Any plan to expand the archive to other states or cities?
Well, it's funny that you should ask. With my arrival here in Florida, there's some interest here in this region, in the Tampa Bay region, in developing an open data platform that includes data from multiple transportation agencies. And so I've been discussing with some colleagues here an idea of creating a portal for the Tampa Bay region. There are some data sources and data portals, more generally speaking, available here in Florida. But I'm definitely interested in expanding and carrying the philosophy of the openly shared data available as a platform for researchers, for consultants, for getting people excited about transportation.
Okay.
Let's see what happens.
Now, along those lines of fusing data from different sources, you and your colleagues published an interesting paper in the Public Transport Journal called Quantifying the Joint Impacts of Stop Locations, Signalized Intersections, and Traffic Conditions on Bus Travel Time. According to your research, what are the main factors that affect bus travel time?
Well, yeah, thanks for the question. I worked with the transit agency in Portland, TriMet, for many years, using their automatic vehicle location system and automatic passenger counting system to generate performance measures and to generate some tools aimed at helping people in the transit industry understand the performance of their system better and solve some very specific problems. So this project, or this paper, I worked on with my colleague Miguel Filiozzi from Portland State and Wei Fang, who was a PhD student there. And so the idea in this paper was to look at at a very detailed level, at the bus stop level, performance of a transit route in relation to the signalized intersections that it was passing through. And in fact, those signalized intersections include a transit priority system that receives a radio message from the bus if it's late. And so then the signal software will adjust itself to provide either an early green or to extend the green. So we were interested in trying to understand jointly what type of stop location, whether the stop is on the upstream side of an intersection or on the downstream side of an intersection, what sort of priority was being granted at the intersection for the bus, and then trying to understand whether the traffic conditions were congested or uncongested. And just as a quick example, you can imagine that if the bus is traveling along and it's late, and so it's asking for priority, and if the bus stop is upstream of the signal, the bus still has to stop and serve the stop at that location. So by the time the bus can accelerate again, that it may have missed its chance to pass through the green light. So that even if priority was granted, the bus couldn't take advantage of it. And especially if there's congestion in the intersection, a similar thing would apply even if the bus stop was on the far side of the intersection. So the bus is granted priority and crosses the intersection and then stops to serve passengers, but then can't get back out into traffic because of congested conditions. So I think in that particular project, we did find that the way that signal priority was being operated was a little bit limited due to technological limitations at the time that it was installed. So there were some big lessons learned about how to improve the ability for buses to receive signal priority, and some of those things are being implemented now. I think we also worked with TriMet using their own data to help them understand the impacts of essentially the spacing between the bus stops. This in the transit industry has long been a complicated topic. Generally speaking, if you reduce the number of bus stops, you impact the accessibility of the system, but you can potentially improve the travel time. You can shorten the travel time of the bus, thus making, from that perspective, the transit system more attractive. So it's a very interesting dynamic. If you reduce the number of stops or increase the spacing between the stops, some people might feel that the system is less accessible to them. They may have to walk or travel a longer distance to get to their stop. But once they're on the vehicle, their travel time might be shorter or more reliable. So we've done published a couple papers on that as well, creating essentially a tool to at least allow an analyst to explore the trade-offs between stop spacing and travel time. And there are many more, I think, tools that can be developed to allow transit agencies to understand the impacts of different improvements to their system. Certainly, there are some interesting advancements with the way transit fares are being paid. They're being paid with an app or in some sort of automated way, which can also improve the transit travel time. So I think in the fleet area, including transit fleets and so on, there's a lot that can be learned. And I think as a researcher, I'm always interested in generating something, a product that can be used by somebody who's trying to solve real problems. So that's a personal interest of mine. I think it also makes research and the work that we do more interesting for students, more attractive, to try to attract more people to the transportation profession.
Yeah, that's interesting. Unique problems that we have with public transportation that many people may not think about.
Exactly. And it is very exciting. I think it's a very exciting time in transportation in general. And, some of the debates in the media and among academics and others, policymakers, about the future of transportation. I, for one, believe that public transportation has a very bright future, especially in our big cities. But it certainly we're at a very interesting time in trying to figure out what's going to happen next.
Yeah. So you spent a number of years as a professor at Portland State University. Can you share your opinion on how Portland is experimenting with smart mobility and transportation electrification with organizations like Drive Oregon?
Sure. Yeah, I've been away from Portland now for a few years. I was there for about 11 years. I'm not a Portland native, but I became quite fond of the city and worked quite closely with a number of great friends and colleagues there. I think Portland has some advantages in that it's fairly compact and that there's already a culture of collaboration. And I know that they were one of the finalists in the Smart Cities competition that happened a couple of years ago under the U.S. Department of Transportation. And so I know Drive Oregon is now called fourth, and I know that they're doing some great things. They started by bringing publicly available charging stations to downtown Portland, I think 8 or 9 years ago. On the west coast of the U.S., due to the electricity sources being mostly renewable, electric vehicles are quite attractive in terms of their improvement in the carbon footprint. So Portland has been sort of an ideal place where a lot of auto manufacturers have introduced electric vehicles. I think the electric vehicle uptake there has been quite strong, and I think the city and the electric power company and other partners, including Portland State, have been pretty forward-looking in thinking about how a smart city could look and what kind of collaborations are needed to make those happen. I would say, to put in a little plug for Tampa, Florida, that we're working with the city here to develop a smart city alliance in this region. And there's a similar amount of passion, I would say, from the city of Tampa, from USF, and many other partners in the community. So I think it's been great to see that many players in multiple cities around the country are thinking about taking a smart city approach where they're bringing together stakeholders, where they're sharing data, where they're trying to engage also with citizens. And I think a big part of the smart city focus is on citizen engagement and helping people understand more about the impact of their decisions on energy consumption and on emissions. And so I think that's one thing I've always liked about transportation, that the more you give people, citizens, information about the impacts of their decisions, they will sort it out. They will figure out how to improve their situation, and quite often that can lead to aggregated improvements as well.
Yeah, that's kind of the idea behind crowdsourcing.
Exactly. Yeah, putting some of the power in the hands of the people and in the hands of innovators and developers, and honestly, young people. Obviously, we're working at universities, and so we care about, you and I care about inspiring the next generation of transportation professionals. So I think that's a big motivator for me.
Yeah, absolutely. So I have a high-level question for you here. I just am curious about your opinion on the impact and the effect that intelligent transportation systems, and more specifically driverless vehicles, will have on the environment and on society as a whole.
Yeah, it's a very good question. I think it's been clear during my years working in transportation that the development of the intelligent transportation systems concept that started as the intelligent vehicle highway systems concept, I think has resulted in a lot of great outcomes, a lot of great projects and policies and programs. But I think that the advancements in in automation and communications that are happening now and have been happening for the last few years, and I might add electrification to that, I think that the advancements in those three areas are and will be much more transformative than what we might call the ITS evolution over the last 20 years or so. And I think it isn't exactly clear what the outcome is going to be. The only thing that I know is that we all need to be at the table. And in the transportation arena, I personally don't want to simply be a victim of these technology advancements, but I think we all need to be at the table helping shape the future, helping to be, more, proactive about how technological advances reach the consumer and start having an impact on our society. I think there are different directions that the effect of driverless vehicles can take us. I think on one end of the spectrum, automation and driverless vehicles can really be freeing and really provide life-changing opportunities for people with disabilities, for people who, for whatever reason, are not experiencing the levels of mobility that they desire. I think there could be unintended consequences as well. So that's why I would say we all want to be at the table to be proactive about the future. The other thing about the direction that we're heading is it's not going to happen overnight. And, the transformations will take time and will be iterative, but they are happening, and they're happening fast. So that's why I would encourage young people to get involved in transportation and to, they're going to be the next generation of leaders who will basically be dealing with and living in the world that gets created. And so I think we all should play a role in creating the kind of society that we want, where, we still, as human beings, want to live in communities that are desirable, and, the advantages, we want to benefit from the advantages of automation, but still remember that we're a society and that it's important for us as humans to interact face to face. I'm saying that on a podcast, which is kind of funny, I know.
Yeah. Okay, great. Well, thank you so much for your participation in the podcast today and for sharing with us some of your experiences over your career so far and the different experiences that you've had. So we really appreciate that.
Thank you, Jeff. It was great talking with you. And anyone who's listening, thanks for listening if you made it all the way through. And feel free to contact me if you would like to discuss any of these things further.
All right, great. Thank you.
Thanks and have a great day.
Thank you, Jeffrey. Professor Bertini, it was an honor to have you here. I'm sure all our listeners enjoyed the interview. Dear listeners, either you are a researcher in intelligent transportation field or are just interested, don't hesitate to contact us. We are recruiting volunteers and your help will be highly appreciated. Contact us on our email at ITSPodcast@gmail.com or just simply message us on any of our social media. Dear friends, don't forget to subscribe and share this episode. Comments and suggestions are welcome. This podcast is sponsored by IEEE Intelligent Transportation System Society. This was Dr. Mayam Kavishkar from IEEE ITS Society.